Every single day, your cloud environments are having thousands, maybe millions of conversations with the public internet. And if you're a senior cloud architect, your biggest challenge is knowing exactly what's being said. Are they sharing sensitive data? Are they talking to malicious actors? Let's dive in and architect a solution to control that entire conversation. Seriously, think about it for a second. Your apps are constantly reaching out for API calls, software updates, data transfers, you name it. But here's the thing. Every single one of those connections is a potential leak. It's a potential backdoor for data exfiltration. So the question you have to ask yourself is, are you absolutely confident that every outbound conversation is safe, sanctioned, and secure? This isn't just a hypothetical. It's the very foundation of your security posture. All right, for this explainer, you're in the driver's seat. You're the senior multi-cloud architect. Your company is running on AWS, Azure, and GCP, and the CISO just handed you a mission. And it's a critical one. Design and implement a single, unified strategy to control all outbound traffic, no exceptions. We're talking total visibility, total control, and a rock-solid defense. Okay, so before we can start architecting a solution, we really need to break down the problem. We have to understand precisely what we're up against, and frankly, the consequences of getting this wrong. Let's define the challenge. So what is egress traffic? Honestly, it's pretty simple. It's just any data that's heading out of your network. The best way to think about it is like your cloud environment is a high security facility. You've got these super strong walls and checkpoints for anyone trying to come in, right? Well, egress is the exit door. And if that door is just wide open and unguarded, anything or anyone can just slip right out without you ever knowing. And an unguarded exit door is a security nightmare. We're not just talking about data exfiltration, where your most valuable company secrets just walk right out the front door. We're talking about malware calling home to its command and control servers, developers connecting to unsanctioned services and creating shadow IT, or even attackers completely bypassing your internal security controls. So let's be clear, controlling egress is so much more than just preventing data loss. It's about shutting down entire classes of attack vectors and keeping your operations intact. Okay, we've defined the problem. It's a big one. Now let's architect the solution. What we need is a blueprint, a set of universal principles that give us a consistent security posture, whether we're on AWS, Azure, or GCP. Because in a multi-cloud world, a unified framework is really the only way to tame all that complexity. Our entire blueprint is built on 3 simple, non-negotiable pillars. That's it. First, strict allow lists to define exactly who we're allowed to talk to. Second, centralized traffic inspection so we can actually analyze what's in that traffic. And third, comprehensive logging to record everything. These 3 pillars together, they form a really powerful, unbreakable chain of security. Let's start with pillar 1, allow lists. This is the absolute foundation. Instead of trying to play a never-ending game of whack-a-mole, blocking all the bad places on the internet, we just flip the logic completely. We start with a deny-all policy. Nothing gets out, period, unless it's going to a destination on our pre-approved, explicitly trusted list. This is just the principle of least privilege, but applied to your network traffic. It's a game changer. Now, just because your traffic is going to an approved destination, like a trusted partner's API, that doesn't automatically mean the content of that traffic is safe. That's where pillar 2, inspection, comes in. This is like our digital customs agent. It needs to perform deep packet inspection to literally look inside the data. We're talking about things like TLS inspection to decrypt and analyze encrypted traffic, hunt for malware signatures, or spot sensitive data patterns like credit card numbers before they even have a chance to leave our network. And that brings us to our final pillar, logging. You've heard it a million times, but it's true. If you don't log it, it didn't happen. We need a detailed, systematic record of every single connection attempt, both the ones we allowed and the ones we denied. This log becomes your single source of truth for compliance audits, for threat hunting when you're looking for weird patterns, and for forensics when you're in the middle of an incident response. It's absolutely crucial. Okay, so we have our blueprint, we have our 3 pillars. Now let's get practical. Let's move from theory to reality. As the senior architect, you have to know how to actually implement this framework using the native tools inside each cloud. So let's see how this actually builds out across that multi-cloud landscape. So each cloud provider gives us the building blocks we need, but with some pretty important differences. In AWS and GCP, you have services like NAT Gateway and Cloud NAT. Their main job is to centralize your outbound traffic through a single point, which is a critical first step.
Azure, on the other hand, gives you Azure Firewall, which is a more all-in-one solution. It does that centralization, but it also has stateful filtering and policy enforcement built right in. To get that same level of control in AWS and GCP, you'll need to combine their NAT services with other tools, like a network firewall.
So, we've designed the blueprint, we've picked our tools. Now let's take a step back and look at the big picture. What's the real strategic payoff for the business now that your architecture is in place? What did all this work get us? The payoff for doing this right is absolutely immense. You've gone from having 3 different siloed security models to one single unified posture. By cutting off all those unsanctioned outbound paths, you've just massively reduced your attack surface. Your policies are now consistent, they're auditable, they're enforceable everywhere. And that doesn't just make compliance way easier, it lets your security team finally shift from being reactive to being proactive, hunting for threats with a level of visibility they've never had before. So your framework is built, your policies are active, but the job isn't done. In fact, this is where the real intelligence gathering begins. As you start analyzing those logs, what patterns are you going to see? Will it be the expected traffic to update servers and code repositories, or will you find something unexpected? The subtle signs of a hidden threat. The answers are now in your data. Your job is to go find them.